Hey everybody, welcome to the chapter 11 Excel problem. This one's pretty quick and easy. We're going to learn some functions you may not have ever used in Excel. Maybe you have, depending on your background and your situations. But we're going to learn about net present value function and IRR, internal rate of return. So really, these are just functions that allow us to evaluate potential investments or uses of our funds. And they take into account the fact that money we have today may be worth more than money we would get years down the road. And the reason that money that we have today is worth more than money we have down the road is that if I earn money today, I can then reinvest that money and earn interest on it in the future. So if I get, if I offer you $10 today or $10 20 years from now, that $10 today could grow to be worth a lot more than what $10 20 years from now just received as a flat $10 would be worth. And so when companies are doing NPV and IRR calculations, they set a rate of return that is their base rate of return that they want to earn on investments. And so I'll usually call that a hurdle rate or a target rate of return. This book calls it the WACC. So that's what we're going to use. So anyway, so let's just go ahead. So we have plan A and plan B, and both of these involve investing some money up front and then getting positive cash flow in the future for the next 20 years. And let me see here. Whoops, let me zoom in a little bit so it's a little easier to see. And so we're supposed to evaluate them. So to figure out the net present value, what I have to do is I'll show you. I'm going to use the net NPV function, okay, which requires us to put in the rate and then a comma, and then we're just going to highlight all of these positive cash flows. So I'm going to say the cash flow from year 1 all the way to year 20. And I'll close the parenthesis, and that will give me the net present value or the present values of those future cash flows. So what is and this is all in millions of dollars, by the way. So what is $6.39 million worth a year from now? Plus what is $6.39 million worth? Not worth a year from now, but what is $6.39 a year from now worth in today's dollars? Okay. Plus what is $6.39 million received in 2 years worth in today's dollars, plus 3, plus 4, plus 5, all the way to 20. So that gives us the present value of the future cash flows. And to find the net present value, now we're just going to take the initial cost of the investment, which is right here. And since it's shown as a negative, we're going to just do that amount plus. So in essence, we're saying that negative amount, which is the initial cost, plus the net present value of all of the future cash flows. And that will give us what we call net present value. So something important to note about net present value is that if it was 0, it wouldn't mean that the investment didn't make any money. It would mean the investment exactly made the rate of 9%. So any amount greater than 0 on net present value means that we earned a return that is greater than the interest rate, that our target interest rate. So in this case, this investment significantly beats our target rate of 9% with a positive net present value of 18.33 million. All right, so we'll do the same thing for the second one. This time I'll just go ahead and say it equals the initial cash flow or cash payment out plus the net present value of, and then I hit the interest rate, comma, all of the remaining years. What did I do wrong? I don't think I did anything wrong. Okay. Well, it seems to be having a hard time. NPV, rate, and then the values. Go ahead and try and re-highlight those. Maybe it just didn't like that I didn't put a second closing parenthesis. Aha, there it is. All right. So both of these have positive net present values, which means they're both beating our 9% target rate of return. But we can see investment A seems to be to have a slightly higher net present value. Okay. So our second measure we can use is something called internal rate of return, or IRR. So this one uses a function in Excel that just says equals IRR. And then all we do is highlight the whole thing. So the negative cash flow up front, and then the positive cash flows stretching into the future. Close the parenthesis, boom, it gives it to us. So project one has a 15% internal rate of return. IRR, highlight all of the cash flows. All right, so we can see this one shows a higher rate of return. And that's based primarily on the fact that we paid out less money up front. So that return coming back gives us a better rate of return. That being said, if someone was going to say, like, which of these two should you invest in, recognize that they both beat our target rate. And the first one, plan A, is actually going to bring us a higher net present value. And so now if we had money to do both, or if it were feasible, this looks like they're mutually exclusive, so it probably isn't. But sometimes we have two options, and if we could do them both and could afford it, it would be good. As long as they both have positive net present values, they're good investments. But if we could only choose one, even though project B has a higher internal rate of return, we would instead go for project A because it has a higher net present value, meaning it's actually going to bring us a greater return overall. And then in just sheer dollars, okay, this one, if we highlight all of those, and we can see our sum is 127 million. So we're going to put in 40 million and then receive 127 million over the next 20 years. And so that's going to bring us in a profit of what, 87.8 million. Here, this is 58.2 minus the 13 is going to bring us in about 45. And so the higher net present value is usually the better investment, even if the rate of return is higher on B. If they're not mutually exclusive, then go for it, invest in both of them, because they're both going to make money for you. Okay. All right. So nice. This Excel spreadsheet was set up so that it automatically graphed these net present values for us based on different discount rates. Okay, so we can see the NPV profile here, the blue one, which is for project A, and the orange one for project B. And we can see that these two cross. So when we make a graph like this, we can estimate, we can probably look and see that that is somewhere between 11 and 12. I can't tell for sure, but roughly between 11 and 12%. So I would guess either 11% or 12% for my crossover. But I can calculate that crossover just by taking the difference between each of these values. So I'm just going to say this equals the plan A amount minus the plan B amount. I'm going to use my little nail here and fill to get the difference between all of these all the way down. And then we'll do equals IRR. And then we'll highlight all of those cash flows, including the negative starting. All right, and there it is, 11.4%. So our graph was pretty close, somewhere between 11 and 12. So our crossover rate is 11.4%. So what that means is that if our hurdle rate was set at 11.4% instead of 9%, right at 11.4% is the point at which these two plans would have equivalent rates of return. Okay, it would be equivalently valuable to us, I guess. All right, so that's it for this one. So hopefully that wasn't too bad. And good luck with the rest of the assignment, and don't be afraid to reach out if you need help.